Okay. This is where we left off. This is our two-dimensional sketch. Quite the massive piece of work here. But still not quite detailed enough. I think I want to add a few more things before we go 3D with it. Don't quite have all of the information we need. We've got a really good chunk of it. Don't quite have all of it. I think a few more things that I would like to add are some dimensional elements to our support structure beams, as well as defining more this arc here. It's not a square boxy angle, as we can see over here from the actual design here. They've done they've rounded it off here. They've got this gusset as well. Let's take a look at what they did down here to join this to join these large beams to the frame. What looks like they've done is they have So I think what they may have done, one way of doing this, is taking this bar here, having one bar here, they welded it at this angle, round bar at an angle. They welded a straight joint that goes straight down, and that secondary joint goes between both of these frame plates. Probably goes right into a hole on one of the on both top side of the frame plate and the bottom side of the frame plate, and then welded, which very likely means that the thickness of the frame plate and the thickness of this aluminum tube are the same for easy welding. So probably a 1/16 of an inch wall thickness for everything. We can probably see up here too, this structural member. Oh, it looks a little thicker, maybe 1/8 of an inch. Okay. Yeah, let's go ahead and add a few more details. We might want to, like we had mentioned last time, is get this pivot point going with a drop-down pivot point, and then define the stroke length as well of this cylinder. Well, those will be things that we'll need to do in the future. Let's see, I want to take a look and see what they've done for their shooter. So you can see here, this is one of their constant force springs that they have. They have chain that runs this way that's likely to pull the shooter back. And I don't know what they use to release it, except I know I do. I talked to them at competition, and they used a seatbelt buckle. They hacked a seatbelt buckle to do exactly what they wanted. They just push a button with the pneumatic cylinder, I believe. They push the seatbelt buckle button, and it will release it. Very similar to how another team did it with a doorknob, where you twist the thing with a servo motor, or with a much probably beefier than a servo motor, but you twist it, and it pulls the mechanism out of the way to let it go, fire it, release it. Much better than what our team did, which was hack a super shifter and shift out of a second gear into the first gear, where it would switch into no gear and let it rip. So let's go ahead and add some more of this detail here. So I'm going to edit the sketch again. Quite a bit of detail. You can see here we don't need all of this material. We can likely cut a few corners. Make that better. We've got this here. I'm going to take this and Yeah, let's start down here. Let's add thickness to this beam. So I'm going to take the offset entities tool. It's the fastest way to do it. I don't want this to be offsetting up here too. I want to control that. So I'm going to hit select chain, deselect select chain, so it's just the things I select. And how much is this? This is probably 1.5 inch tube. Yeah, 1.5 inch maybe. Let's give it a shot. 1.5 inch. And we also want 1.5 inch to apply to that one. And it looks good. Now that I think about it, yeah, no, let's do this. So there's our tube, both tubes. We want to be careful because our center point, pivot point, needs to be on this tube. Or actually, how do they solve it? Let's look and see how they solved it. I want to see how they've mounted their pivot point. Well, you can see the giant sprocket they have is up here. Maybe we can glean some more data here. Yes, we can. Can't zoom in any farther, but here we can see that there is, it's very blurry, but it looks like they definitely do center their pivot point on their arm. I'm not sure exactly what mechanism they have used to hold on to their pivot point. They probably just welded another bar to this assembly. But the point is, the center point is here in the middle, not on this edge, especially not in the corner. So we should be able to, just so I can clean things up, I want to, makes it look much nicer. All right, let's see if we can move this, release the pivot point from this actual, from the actual beam. So I think I might have to get rid of a few things. SolidWorks adds its own dimensions. If I do this, its own relations, and do this, re-add this line. That line was coincident with that. It goes up here, and now this and that collinear. There we go. Now we need to define how this is going to be centered on here, and now I'm just going to center it with some tangents here on the circle. There we go. I'm not going to explain every single relation that I add, but I trust that you will watch the video in slow motion or something and watch exactly what I do. That's the intention here. You can see how it's all defined. So now I still have a relation to add somehow. I can see how this is still underdefined. And the thing was, this and that were going to be parallel to each other. Now, yeah, the one thing left to add is the length here. I'm just going to say that the distance between this to there, this edge distance, we'll give it an extra inch. Oh goodness, I didn't like it. Try that one more time. It's not liking me defining this line. Try it a few different ways because it should. There we go. Now it's let me give that 1 inch. And I'm just going to move these sample dimensions, or these read-only dimensions, to work on the center point. You can also change dimensions locations by selecting it first, and this box that's at the tip, you can click and drag that box and place, redefine the smart dimension without actually deleting it. Super handy. Okay, so now that's back. We see here that this is running all the way up against the edge, which is pretty close to what they do. Very, very close. Of course, it won't be completely at the edge, so let's fix that. Let's define that so it's not completely on the edge. Well, I'm going to have to pull some trickery here to get this line on its own. So what I'm going to do is I'm just going to cheat a little bit. I'm going to hit the trim, break that coincident joint, that merged joint. And now somehow I should be able to, this is still merged somehow. Keep poking around. Nope. Not the relation I was intending. Perpendicular. Oh, you know what? I should break this one free too. That one might be the problem child. I might have to break both of them free in order to get one. Well, I'm thinking that this looks fine. I wonder what would happen if we got rid of that. Oh, very, very exciting. I do not know what is setting this angle, but I want to change it. That's collinear, which is fine. Make sure that this isn't parallel with anything else. It's all related relative to each other, which is good. All right, well, we might have to just do that and start over. So there's some relation that was invisible relation that was on that line. I just deleted that line so we could start fresh. And re-added it, of course. So I'm going to make this coincident with the line, not necessarily the point, just the line. And now I'll still be able to move it inwards. Just like that. Come on. My computer is not thinking as fast as it used to. I'm going to add another circle here. One that's at this joint. Coincident with the point. Tangent here. Bring this back. Oops. Bring that back in, and then tangent here. And then that'll set the distance. We can set these two equal to each other to make the thickness between the rods the same. Just got to make sure that this and that are parallel. There we go. Now these are the rods are the same thickness. This and that should be coincident, just so it's nice and clean. That should be construction. Now we should be able to drag this back fairly easily. There. Here and there. We'll say that they set that in 1/2 inch. And then come over here and do the same kind of thing. So drag this back a bit. Looks like it's not computing that very well. Didn't like that. So what I'll do is I'll use the trim. And then I'll use extend. Well, it's hard to click and drag this away, so I'm going to use a smart dimension and increase the number on the smart dimension to separate it. Oh, that's changing the angle, not necessarily the distance. This rod is away from, so I'm going to have to delete this line too, just like I had to do the other. Just delete that, re-add it, just so I get rid of those invisible relations that it added. This and this parallel to each other. Make sure that that and that are coincident still. This and this are tangent. And now I can make this and that coincident to each other. It'll drop it down. Now I can take this and move it back, just like that. That's what I wanted to do. And this distance wants to be 1.5. I know it's going to be completely fine in the end. We just gotta coax SolidWorks into thinking that too. So when I see the model explode into red and yellow, I don't get too scared. There's a way around it. This point here is, I think, might be causing some issues. Just some intuition. Look at that. Now we're free and clear of moving stuff around. So this is firmly at 1.5. Set this, that. We'll make it symmetrical to the other, so I'm just going to make a quick equation. Or is that the wrong? That's the wrong one, sorry. What's this one? There. And now I will add that point back in. Same constraints and everything. It's just SolidWorks gets finicky once the sketches get this complicated. So how can I define this more? What moves? Well, that's difficult to tell. Computer's taking a long time to think. Oh, there we go. Aha. It did move it, and look at that. I can see that this is intended to be perpendicular. That way the forces will travel very nicely straight into the beam. I can also see that this and this are no longer parallel to each other like they had like they were intended to. And wouldn't you know, after those two things are taken care of, it's fantastic. And now that those are fully defined, I can come back and finish adding constraints on this point. And I'll set this to be 2 inches. I think that's what we had it at before. If not, it's a good number. Okay, this really helps. This was, I think, the most critical piece. We'll be able to fudge these this contour up here. It's not critical that we get this the right shape. What's critical is we have all the pivot points in the right location. As such, there's because of that, we should make sure that this pivot point here is exactly the way we want it. So what we should do is, this is going to be the last thing we're going to modify in the 2D sketch before we're ready to go 3D. So I'm going to look at it here. They've got a pivot point. They've just got maybe 2 inches, 2.5 inches between the pivot point and the center of the bar. Just looking at the similarities between them. Okay. So what's going to happen is I'm going to take this pivot point, and it's no longer going to be concentric. The edge. Isn't it funny how you delete a relation and then it becomes unsolvable? It was solved before. Should be underdefined now. That's how I know some of these things are just bogus. Trying to get this pivot point to come off of this circle. So I'm just going to delete this circle. There we go, look at that. And this somehow is still defined. This slope is defined somehow. How is that slope defined? Oh, it's parallel to something. It's parallel to that, so that's why the slope is defined. It's parallel to that. Okay, that's fine. So the important thing is that the okay, well, this is two different things. So there's the pivot point and there's the actual bar. The end of the bar currently is the pivot point in this drawing, but the end of the bar will not be the pivot point in the actual robot. See, the end of the bar is here, but the pivot point's up there. So we're going to need to make a new pivot point, or make a new bar, because currently they're kind of constrained onto each other. I'm thinking about the best way to do this. So I'm thinking I'm going to try to get this point. I'm just going to move it out here. I'm going to leave these here. I'm not going to delete anything. I think we can get away without deleting anything. Delete those two. Now I should be able to move this freely. Oh, I have parallel relations that I need to delete. That remains. Oh, it's this midpoint relation. And the perpendicular down here. And there. Okay. Now, this should be completely independent. Perfect. That's exactly what I wanted to see. So the pivot point is going to be up here somewhere, way up there. that'll make it very easy for us to mount and service. So we will make that centered by just putting some tangents on this circle. Circle just helps me see kind of a radius of do not touch this area, kind of a structural area, do not touch. And now, you know what? Scratch that. I think there's a better way. So I'm going back to a time when I didn't delete circles. This time. Keeping that here. Except oh, okay, now I get it. Okay, this is what's going to happen now. I want to separate both of these bars from each other, the ghost bar and this actual bar. So in hopes of doing that, I'm going to take those 2 points away from each other. They were merged before, and the only way to unmerge them is to delete the intersection. And you can do that by using trim. So currently these are still tied together. Now I think these circles are merged at the center point, so I have to get rid of them too. Perfect, that's what I wanted to see. Now we'll re-add those circles. Their center points were merged, or they were concentric or something. And that was keeping them from separating, because what I want is them to be separated, and it'll make sense here once we see it all come together. This is the pace at which I think. So now this merges to that, and this, ooh, come back here, buddy, merges to that. Now we have 2 completely separate pieces. Now they are still tied with an equals relation, I believe. I think that's how they're moving together. If not, these 2 things should be equal. This might explode. Oh, nope, they're equal to each other. Very good. So the next thing would be to add the other imaginary bar. And this, where they intersect, this is the same bar on both of them. They're equal. And construction. Now, wherever we place this bar is going to be, that'll be our pivot point. And I'll place it, oops, don't want to do that. I'm going to bring that line back, bring this line back. I'm going to place it at the center point of this arc that I'm drawing. Make this arc tangent on both ends, so that way it's centered, and that center point will actually be the middle of the line too. And then this should be legit. There we go, look at that. The next thing is we need to define, there's still more to define, like the location of this thing, as well as the angle between these 2 guys. And this is going to be perpendicular, just for simplicity's sake. Makes it really easy to manufacture that way. Now one of these is fully defined in space, and that specific one is the the intake one. And that's not quite fully defined in space is the shooter one. Yeah, the intake one is not fully defined. The shooter one's fully defined because the shooter one has to be parallel. So that one's, this intake one is not defined yet. Oops, looks like I got it to a place it can't go back to, so I'm going to pull D. And now the next thing will be, I think the next important thing is going to be defining the length of this line. And I think that was 2.5 inches is what I estimated before. Great. Now the next thing is figuring out how this can move still. Okay. I accidentally added a relation. Don't want that. So this can still move because this is not perpendicular. As soon as I add that, it should be fully defined. Perfect. So now you can see here, this one. So this solid lozenge shape will rotate about that point to be in that lozenge shape. And so it wasn't quite as simple as it was before where it was pivoting at this point. Now it's pivoting up here across a 1.5 inch, 2.5 inch line. And now it kind of moves back a little bit. That makes it super easy for manufacturing and building the robot. But all of the relations that we set up down here have held true. You can see here that the intersection at this specific point, that point hasn't changed at all. It's just the left end that's changed. So it still is going to be within 2 inches. What may have changed, no, we're good. This, actually, yeah, one thing that I forgot to do was change the pivot point from here to there for this large overhanging circle. So we should do that. There's no way to change that. I think it got merged, so I'm going to have to redraw the circle and re-add those relations. Probably doesn't matter too much, this specific detail, but you can see here it's changed a little bit, so it would have actually been a little bit less than 2 inches because of that change in pivot point location. So I like to make sure small details like that get resolved. Now you can see here the length of that has shrunk just a tiny bit, but that'll make sure that it's at 2 inches. 2 inches inside the drivetrain. And I set it at 2 inches because there's likely going to be at least a 1 inch flange on here, and that would give us 1 inch beyond that 1 inch flange. And we can always come back to that later. All right, that makes me feel better. Now we've got two of the really important details already taken care of. We've got this bar here is now dimensional. These two sport bars are dimensional, and this rolling bar is dimensional, and it has a pivot point that's in a more realistic location. This sharp corner here probably won't exist on the robot. What's going to end up happening is we're going to cut this corner, probably with a gusset, and then we'll smooth this out up here. In fact, I think what they ended up doing is they put a bar there. All right, this will be continued in just a second.